In this video, we're just going to actually go ahead and solve this integral on the right-hand side. And mind you, just to give you a flavor of what to expect in the upcoming class. So like I said, we're going to use u-substitution here. But again, to motivate y, we see that we have this 3x cubed function here, where we know if we differentiate that 3x cubed, we're going to get something that looks like, well, a 9x squared. And again, that x squared, a part of that derivative, we see that x squared kind of sitting there out in front of that second function, that 7x squared sitting out in front. We have the product of two functions, 7x cubed, or 7x squared, excuse me, and that sine of 3x cubed. So let's go ahead and actually apply u-substitution here. So we're going to let u equal that thing we just took the derivative of, that 3x squared. So if we go ahead and set inside of our function what we have so far, well, we have that 7x squared sitting out in front. We have sine. Well, we just have sine of u now, since we just called 3x cubed equal to u. And the last thing we get to do is, well, we need to figure out what dx is. So this will be our main goal, figuring out what dx is in terms of our new function variable du. So I'm actually going to go ahead and get rid of this dx on the second integral. And what we're going to get to do is differentiate that u function with respect to x. So we just have du dx using our derivative notation. Well, this is 9x squared. And the nice thing that we can do is, well, we can think about that du, like in that numerator, or that dx sitting down there in that denominator separately. So what we could do next is just cross multiply that dx onto the other side. So we have du is equal to 9x squared all times dx. And well, what we need to figure out is what dx is in terms of du. So we can just divide both sides now by 9x squared to get dx fully in terms of du. So I'll just say we divide both sides by 9x squared. And what we get is, well, 1 over 9x squared du is equal to dx. And this, calculus friends, is a relationship that we get to put into that integral, because now we know what dx is in terms of du. So let's go ahead and substitute that in. So we have that this is equal to 1 over 9x squared times du, sitting on top of that rest of the integral. And I'll just put up a little divider here. And what we see is, well, those x squareds will cancel out. And the integral that we actually get to solve is now, well, 7 over 9 times sine of u du. And using our integration rules, we know, well, that 7 over 9 we can pull out in front, since that's just a constant. It doesn't depend on our integration variable u at all. So we really just have to ask ourselves, what is the antiderivative of sine? And well, hopefully we can all recall that that's actually equal to minus cosine of u. So our antiderivative in this case is minus 7 over 9 cosine of u plus our integration constant c. But we're not done yet, because we still have that cosine in terms of u. We want to get back to the original variable, which is our variable x. So just going back to what we had before, where we let u equal 3x cubed, we just get to substitute in that 3x cubed in for that u last. So our final antiderivative of this problem is minus 7 over 9 cosine of 3x cubed plus c. And we're going to be going over many other problems like this in class, but hopefully this gives you a sense of the mechanics that we're going to use for u-substitution.